There are many ways to represent functions, and using a table is one of the ways. For example, we can use a table to represent order pairs x, y, and we can make a same table that would organize these order pairs like so. So all the x values would go into the x column of the table. So for example, 9, 10, 11, and 12. And all the y values, that's the output of that x input, is going to be on the y column of the table. So for example, if we put in 9, we would get out -5. So -5 would be corresponding to 9. And then we have -2, 1, and 4. Make sure that the pairs are lined up. So when you read it again, you can still see, okay, 9, -5, 9, -5, 10, -2, 10, -2, and so on. Another example is we could use a function table to represent some values in the function. So for example, if we're given a function g of x equals -4x minus 3, then we can input the x values and we'll get outputs of different g values. So for example, if we plug in 5 as the x value, then we're doing -4 times 5 minus 3. And we say times 5 because -4 is the coefficient for x, so whenever a number and a variable together, that means they're multiplying. So if we put that in the calculator, -4 times 5 minus 3 is going to give us an output that's -23. And that would be the output for 5 as the input. Okay, let's do another one. If we put 10 as the x value, then we're plugging in 10 for x. So we will get -4 times 10 minus 3. And that is going to give us -43. So that means when x equals 10, y or g of x is -43. When x value is 15, we'll have -4 times 15 minus 3. And the y value we'd get out would be -63. So that means when x equals 15, g of x equals -63. When x equals 20, we plug in 20, so we have -4 times 20 minus 3. And that would give us a g of x value, -83. So that would be -83.